Very good afternoon. I welcome you all to the session of the live session for this course, IC Engine and Gas Turbine. I request all the learners, those who have registered with this course, to post your question either in the chat box or you also can raise your question here so that we can discuss those questions now. I may mention here that this course is developed jointly by me and my colleague, Professor Viniyak Kulkarni, from the Department of Mechanical Engineering, IIT Guwahati. This is an important core course of the students belong to the Department of Mechanical Engineering, Chemical Engineering, Electrical Engineering, Power Engineering, and Aerospace Engineering. In this course, we have discussed several topics of internal combustion engines, while my colleague Professor Viniyak Kulkarni has discussed about the gas turbine part. Pertaining to the topics related to the internal combustion engine part, I have discussed, and topics those are related to gas turbine units. Those topics have been discussed by my colleague Professor Viniyak Kulkarni. I request learners and those who are attending this session to post your question in the chat box. I shall be happy to interact with you all and to discuss those questions in this session. For the internal combustion engine part or module of this course, I have discussed the basic cycles, then carburation. I have also discussed about the engine nomenclature, processes in an internal combustion engine. Then I have discussed about briefly the combustion part, fuel injection system. I have also discussed about the fuels and solved a few numerical problems from different topics of this particular module. Similarly, several issues, those are related to the gas turbine units, are discussed by my colleague Professor Viniyak Kulkarni. In this particular live session, I would like to discuss questions or any doubts if you have already. So shall request you all to post your question in the chat box so that we can start our discussion now on those questions. Shall request learners, registered students, practicing engineers, faculty members who have enrolled this course to post your question in the chat box, or you also can raise your question here in this session. Internal combustion engine, which is an important part of the applied thermodynamics. Probably you have understood by this time that in this particular module of this course and also for the gas turbine units, certainly we have discussed about the basic thermodynamics, heat transfer aspects, and to some extent fluid mechanics. So this is an important undergraduate course wherein understanding of basic thermodynamics, fluid mechanics, and heat transfer is necessary. I have discussed several topics of this particular course, and while I was discussing all these through this module of this course, I have also solved a few numerical problems essentially to illustrate the conceptual part of this course. Shall request you all to post your question in the chat box, which will indeed help me to start our discussion now. It is also possible that you can email your questions, or if you will be having any doubts to the instructors of this particular course, and we shall be happy to get you back with the solution or answer of those questions or queries. There are also tutorial classes. You also can post your questions therein in the tutorial platform, and we shall certainly try to address those questions or doubts you may have in subsequent days. Dear learners, students, practicing engineers, and faculty members who are registered with this course and attending this live session, I request you all to post your question in the chat box so that we can start our discussion. I got a few queries from several learners of this particular course, and they wanted to know the textbook which they would like to follow for this course. Already I have given or mentioned the textbook name, but again I am telling here, for this particular course, for the internal combustion engine module, you certainly have a few textbooks. I guess my suggestion would be to consult with internal combustion engine, the book authored by Professor V. Ganeshan. Also, there is an important textbook also written by William W. Kulkarni. That book essentially will help you to understand several conceptual parts. Similarly, for the gas turbine part, I have already mentioned the textbook name and also the name of the authors. And most important book is Cohen Rogers Sarvanamattu, that you also can have to understand several topics of this particular module of this course. Registered students, learners, practicing engineers, and my faculty colleagues who have join this live session, or even if you didn't join the live session or would like to join the live session, you can post your question either in the chat box or you can email us the questions, doubts, either you already have or you may have in subsequent days, and we shall be happy to discuss all those queries. Dear learners who are attending this particular session, shall request you all to post your question in the chat box. Since I have discussed about the internal combustion engine module, certainly several subcomponents of this module, I may briefly discuss here that in this particular module of this course, I have discussed about the basic cycles, classification of both two-stroke, four-stroke engines. Though nowadays two-stroke engines are not used, but still I had taken an effort to discuss, to differentiate the main difference between these two types. Then we have also discussed about the two-stroke cycle and four-stroke cycle engines. We have identified different strokes for both types. Then we have discussed about the carburation using a simple float type carburetor. Though carburetor is not used nowadays, yet we have discussed this particular module, and then we have discussed about the combustion, not in details but briefly, and that particular discussion would be helpful, I guess, to understand the fuel air combustion in an engine cylinder. Then we have discussed about the fuel injection system. As you have seen that in a spark ignition engine, air fuel mixture is thoroughly mixed before this mixture is drawn into the engine cylinder, and then that fuel air mixture, which is also known as charge, is compressed, and towards the end of the compression process, ignition is initiated by a spark plug. And we have seen what are the possible difficulties associated with the combustion of the SI engine. Then we have also discussed about the CI engine fuel injection system and combustion. We had seen that for this particular type of engine, only fresh air is taken into the engine cylinder during intake stroke. Then air is compressed inside the cylinder, while the compression ratio for this particular type of engine is higher than that of the SI engine. And again, at the end of the compression stroke, where air is having high pressure and also higher temperature, fuel is injected into the engine cylinder in the form of spray, having finer fuel droplets. And then combustion takes place automatically in absence of any external agent like spark plug. So basically, this is known as self-ignition, because ignition takes place without requiring any external agent like spark plug. Even in this particular type of engine, we have discussed about several problematic issues related to the combustion, and certainly we have also discussed remedial measures should be taken into account while designing as well as engine is under operation to prevent several undesirable phenomena. I should say undesirable phenomenon like detonation and knocking. Then we have discussed about fuel types, characteristics of a fuel typically used in both SI and CI engines. From there, we could define two important index, that is octane number and cetane number. Octane number essentially indicates how well a fuel would be able to resist self-ignition. That means ignition will be initiated by the spark plug only. Similarly, in the context of CI engine combustion, an important problematic issue is the ignition delay. We have also discussed about this part that ignition delay has two components. One is physical delay. Second one is the chemical delay. Physical delay is associated with the mechanical, parts of the engine, because fuel will be sprayed into the engine cylinder by a nozzle. When a nozzle is under operation for a long time, because of several issues like clogging of the nozzle aperture by the particles, nozzle may start malfunctioning. So there will be a delay, because when the engine and the combustion process is designed, it is also designed quite accurately that the amount of fuel must be sprayed in time and the combustion should be completed also in another specified time. Now, in case if the fuel supply to the engine cylinder is getting delayed by this problem, combustion also would be delayed, and that combustion is known as abnormal combustion, incomplete combustion. And it is because of this incomplete and abnormal combustion, engine efficiency will reduce. Not only that, there will be another a few important issues from the perspective of environmental condition. So because of this incomplete combustion, several emission will be there, and those are very, very detrimental for the environment. So question is, whenever we are supplying any fuel to the diesel engine, we must ensure that that particular fuel will certainly be having the ignition delay, accounting for both the physical delay and chemical delay, because chemical delay, which solely depends on the chemical composition of the fuel, chemical structure of the fuel. So to understand what would be the delay period, and certainly this delay period should be as small as possible, an important index is defined that is called cetane number. So we have discussed all these aspects in this particular module, that is internal combustion engine of this course. I now request I have one question, that 4-cylinder engine. Thank you very much for this question. So the question, he would like to know about multi-cylinder engines. Certainly in this particular course, we could not focus on this particular topic. I must suggest you that if you are really interested in this particular topic, we can have discussion, I request you to write me an email so that we can figure out a particular time slot and I can discuss with you. So in particular, you know that for the heavy engines, heavy vehicles, multi-cylinder engines are there. I can just briefly tell you in a multi-cylinder engine, you know that design is very important. That when there will be, you know, power stroke in one cylinder, maybe in another cylinder, that would be the ideal stroke. So basically, in a multi-cylinder engine, if power stroke is happening at a given time, then huge amount of power would be generated. So to redistribute the power, cylinders or, you know, the combustion or ignition is properly designed. And also in a multi-cylinder engine, fuel distribution equally among the cylinders is an involved or important topic. Certainly, I'd like to discuss this particular topic with you. Rather, I shall be more than happy to discuss with you. Please write me an email. I shall figure out a time slot and I will discuss with you. Since the gas turbine unit or this particular module is, you know, this particular module has been discussed by my colleague, Professor Viniyak Kulkarni. Since he could not join today, if you have any issues from this particular module, shall request you all to post or to email that question directly to my colleague, Professor Viniyak Kulkarni. He will certainly get you back with the solution or answer of those questions. Learners, registered students who have joined this course and attending this particular live session today, I request you all to post your questions if you have any by this time, so that we can start our discussion now. This is an important undergraduate course for the students specializing in mechanical engineering, electrical engineering, aerospace engineering, and chemical engineering. Also, power plant engineering. This course is having two important modules, that is internal combustion engine and gas turbine. I must say there are different, you know, areas wherein applied thermodynamics plays important role to learn the processes and also to the operation and also the operation of several components. Internal combustion engine and gas turbine is one of the, you know, applied thermodynamics courses, and in this particular course we have discussed in detail about the, you know, important components, and we have also solved numerical problems essential to illustrate the conceptual part that we have learned. In applied thermodynamics, there are different modules, and all modules are discussed not in detail but in brief. But internal combustion engine and gas turbine, this is the subject wherein several topics of internal combustion engine as well as gas turbine units are discussed in detail. we had also discussed that in internal combustion engine, essentially our objective is to produce power. We would like to get work output at the shaft. And if we say this is, power, then certainly power that is available at the shaft is known as brake horsepower. Horsepower is a unit which is used to measure the power being developed by an internal combustion engine. The power which is developed inside the cylinder, that is known as indicated power. Certainly power available at the shaft is not equal to the indicated power because of several losses. One important loss is the frictional loss. Alongside, you know that because we have learned from our basic thermodynamics course that in classical thermodynamics we talk about energy interaction either in terms of heat or work. So when work is or power is produced inside the cylinder at the piston face, that power is not available at the shaft because of several losses that I have already mentioned. One is the frictional loss. Another important part that we have discussed, that is the engine lubrication system. Piston will be having continuously to and fro movement between two locations, and these two locations are known as top dead center and the bottom dead center. There are many books wherein these two centers are also mentioned by inner dead center and outer dead center. Top dead center is the inner dead center and bottom dead center is known as the outer dead center. So now, since the piston is having spontaneous movement between these two locations when engine is in operation, even when you are not trying to extract some power from the engine, if we just start the engine, still the piston will be having to and fro movement between these two locations. So it is because of this continuous or spontaneous movement of the piston, we need to supply certain amount of lubricant, and that lubricant will certainly reduce the frictional loss. Also, the temperature that would be developed inside the engine cylinder because of this combustion is very, very high, and certainly that rise in temperature will heat up the engine cylinder wall. That temperature may have detrimental impact because thermal crack may generate. So to avoid this particular or this type of unavoidable phenomenon, we need to have proper cooling system as well. So the coolant will be continuously supplied to take away certain amount of heat from the engine cylinder. Had we not designed the engine properly, perhaps the engine cylinder won't work for a long time. So if we would like to have coolant system and the coolant should be supplied, to take away certain amount of heat from the engine cylinder, that coolant should be supplied to the cooling water jacket, which is given at the outer periphery of the engine cylinder wall. So that coolant will reduce the heat. Certainly certain amount of energy will be taken away by this coolant. And you can understand that it is because of this, the total amount of power or energy that would be available at the shaft of the engine is not exactly equal to the energy or power available at the piston face. So this much amount that we are going to get at the shaft of the engine is obtained at the cost of some input energy, and that input energy is the chemical energy that is remaining stored within the fuel. So this energy conversion takes place through a complex mechanical arrangement, and that is basically engine cylinder. We have discussed this part as well in this particular module of this course, that is internal combustion engine. I request learners, registered students, practicing engineers, and my faculty colleague who have registered with this course to post your question in the chat box. Even if you do not have any question for the time being, I request you all to email me the questions. I shall be happy to interact with you all. I shall certainly get you back with the answer of those questions or queries. I can understand that there are no more questions except one. That question is all about the operation of four-cylinder engine. I have advised the learner to write me an email. I shall figure out a time slot and I shall discuss. This is basically the topic wherein we need to focus our attention on the multi-cylinder engine. This part certainly I didn't discuss in this particular module because that was not included in the course content. If you do not have any more question, then I would like to stop the session today now. But before going to stop the session, I once again request you all to email me the questions. If the questions are from the internal combustion engine module of this course, if you will be having questions from the gas turbine module of this course, please feel free to email those questions to my colleague Professor Viniyak Kulkarni. We will certainly get you back with the answer of those queries. You also can post your question in the tutorial platform. We shall be happy to discuss all those. With this, I thank you all very much. I stop this session here. Thank you.